All right, so this video is going to be on figuring out limits in pre-calc. So given that this is pre-calc limits, there are a bunch of other little tricks we have in calculus that we can do to help us do the limits, but I'm going to focus on the stuff that you should be expected to know in pre-calc, and I'm not going to say going to add too much to that. Because I'm a little bit rusty on that part myself, but pre-calc, I think we manage. So the most basic thing about limit is that you first check, can you just simply plug in the number? So if I ask you, what's the limit as x approaches 3? Well, if I plug in 3, what's 3 plus 5? Well, that's just going to be 8, and thus that's the limit. I mean, if you can plug it in, great. Plug it in, figure out what the equation ends up being. There's your answer, right? No harm, no foul. Very easy to do if that happens. If they have this little negative or positive, that just means what happens as x approaches 3 from the lower end, which means that if I'm going from numbers that are less than 3 going up to being what 3 is, then how is this graph behaving? How is this function behaving? So that means that if x is going from 2.9 to 2.99 to 2.999, blah, 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 all the way up to 3. So approaching it from the lower end, as x gets closer and closer to 3, what's this value approaching? But once again, if you can plug in the number directly and you get a value 9 times out of 10, that's the answer anyway. This is the same idea, except it's going from the higher end. So we're going from like 4 on down. So we're going 3.999, 3.99, 3.9, 3.1, 3.0001. We're getting closer and closer to 3, starting from the upper end and going down towards 3. But again, I can still plug in 3. This is going to be 8 still because I can plug it in. Everything's all hunky-dory. So there's my answer. So if you can plug it in, get a value, then you're done. The issues occur when you plug in and you can't do, like, I can't do 2 divided by 0, right? That just doesn't happen. 2 doesn't divide by 0. So if I plug it in, I get an error. Now, that doesn't mean we can't actually get the limit, though. So what we do is we figure out, okay, well, what's happening as x gets closer to 0 from both the left and the right? So what's close to 0? Well, I can do 2 divided by negative 0.1 and 2 divided by positive 0.1. Those are pretty close to 0. And then I can do 2 divided by negative 0.01 and 2 divided by positive 0.01. Again, getting closer to 0 that way. So this is getting closer to 0 on the left. This is getting closer to 0 on the right, because in order for the limit to have an answer, the left and the right approaches have to be the same. So usually we do like about 3 or so. So 0.001, 2.001. Again, I'm just picking numbers that are close to 0 so I can see what's sort of happening here. And to do this, I would use a calculator just so I don't do this all by hand. But what we do here is we say, okay, what's happening? So if I go to y equals and I type in the function 2 over x, right? So instead of me doing this by hand, I can just actually use my table format. So I go second table set, make sure that independent is set to ask. And then once it sets to ask, I can go second graph to my table, and I just plug in whatever x's I want here. So I can plug in all my 3 negatives. So negative 0.1, negative 0.01, negative, negative 0.001. Got that. And then I can do my positives, 0.1, 0.01, and 0.001. And then I can see what's happening here. Well, as x gets bigger and as x gets closer to 0 in the negative direction, this is going to get to negative 2,000. Okay, so it's getting bigger and bigger and bigger. So if I were to plug in a negative 0.00001, right? This is a very, very, very small or large negative. So in terms of this case, small number. This is negative 2 with 6 zeros behind it, essentially. So that's a very, very, very small number, right? This is getting more and more and more towards the negative infinity range, right? So as the bottom number gets closer and closer to 0 on the negative side of things, this is getting towards negative infinity, right? It's just getting bigger and bigger. It's making a bigger and bigger and bigger negative. That's all it's doing. It's making a bigger and bigger and bigger negative. Well, what's happening on the positive side? The exact opposite. It's going from 20 to 200 to 2,000. If I do 0.00001, again, it's getting 2 with 6 zeros behind it, so 2 billion or whatever. So this is getting closer and closer and closer to positive. It's just going to keep growing, right? 2 divided by 0.001 is going to be a really, really, really big number. Well, if I go from the left side, the lower side, and it's a negative infinity, and I go from the right side, the upper side, and it's positive infinity, since these two things do not agree, this is a does not exist. This limit cannot be concluded because the left and the right limits don't agree. You can see this on the graph, actually. If I bring up the graph for this, You can see that there's a split right there, and part of the graph on the negative side jolts down, the positive side on the right hand of the graph jolts up. Since these two sides do not agree, I cannot say what the limit is here. If they both agreed on a direction, then I could. So if they both jumped down or if they both jumped up, aka if this was positive infinity or if this was negative infinity, and they both agreed on what infinity we're going towards, then I can say, well, the limit is positive infinity or negative infinity. I could just pick one of those depending on which side it was going. But since they disagree, I can't do that because the dysfunction there prevents me from reaching a conclusion, essentially. Because if I choose infinity, well, it's not true on that side. If I choose negative infinity, well, it's not true on that side. So I can't choose one or the other, and so we say it does not exist. The rule of thumb basically is a number divided by 0 is going to reach an infinity of sorts, essentially, right? A number divided by 0 is going to reach infinity. Well, if I have a negative number on bottom instead, well, that means it's going to reach towards negative infinity. Since I have a positive numbers over here, as I get to 0, that means it's going to reach to positive infinity. So, again, that's a general rule to keep in mind. The smaller the number is on bottom, the bigger the answer is going to be, right? If I take a number and I divide it by a very small number, that's going to get me a very large answer compared to something I divide by a very big number. So this sort of rule here, as a number divided by 0 is going to approach one of the infinities, is something to keep in your head. And then you can just worry about what type of infinity it is. Is it negative or is it positive? Well, if there's a negative number on bottom because you're going from the left side, it's going to be a negative. If there are positive small numbers on bottom because you're going from the right side, it's going to be positive. So what if they throw this stuff at you, which is usually how difficult it gets here in pre-calc? Well, first thing you should always do is factor. Because if you can cancel out what's having an issue here, because right now if I plug in a 5 on bottom, I'm going to get a 0, and that's going to cause some issues, right? I'll have a 0 on top and a 0 on bottom, and that's usually going to cause some confusion. So I'm going to simply factor the bottom first. So x minus 5, I want two numbers that multiply to negative 10 and add to negative 3, which would be negative 5 and positive 2, right? And again, if I plug in a 5 right now, I get a 0 on top, I get a 0 on bottom, which basically gives me 0 over 0, and that's inconclusive. I can't really deduce much from that. It can be negative infinity, it can be positive infinity, it can be a number for all I know. I simply don't know what's going on when it's 0 over 0. So luckily, though, what happens is I see that, oh, well, these two things can cancel because they're both x minus 5. And so after they cancel, I'm just left with 1 over x plus 2. And hey, I can actually plug a 5 in there. Whoops, x plus 2, not x plus 5. Ah. 1 over x plus 2. And I'm going, hey, I can actually plug in a 5 in there. I can do 1 over 5 plus 2, which is 1/7. And that is indeed my limit here. Because if you can factor out the problem child, if you can factor out the issue, then you can simply plug in what you're taking the limit of and see if you get an answer. And if you can, great, then that's your answer. Or if you can't, maybe the result is something that you can do a little bit more of a deduction on than 0 over 0. So always check to see if you can factor out the problem first, because that's going to make your problem a lot easier. Again, we can see this on the calculator too. If I do x minus 5 over x squared minus 3x minus 10, and I go to my table, well, okay, if I plug in a 5 right away, boom, I get an error, obviously, because again, it's going to make the bottom 0, it's going to make the top 0, it's going to cause me an issue because the bottom of the function can't be 0, right? But if I plug in numbers that are close to 5, if we go from the lower end, let's say, so 4.9, 4.99, 4.999, and then again, 5s are issue. But if we go from the upper end too, so we go say from 5.1, 5.01, 5.001, we can see that, again, the left side and the right side are kind of approaching the same number. It's like 0.14284. Well, I wonder what 1 divided by 7 is. 1 divided by 7 is, well, 0.142857. And that seems to be what they're going to, 0.14288, 0.14284. Well, it makes sense that if I keep going closer and closer to 5, I'm probably going to get to this number right here, which is exactly what happens. This is what's called a hole in the graph. So this graph looks something like this, and then once x hits 5, I have a hole, but then it continues on doing its business here. And right here is where y is going to be about 1/7, right? This would be where 1/7 would occur on the graph if x could be there, but it can't. So it can't exist at that point, but we can say that, you know what, if it could, it'd be 1 over 7. That's kind of what the limit means there, is that if it could exist there, our best guess would be that it would be 1 over 7. Because, again, I could factor out the problem. Now, contrast that to this one here. So this one, well, if I go to factor this, let's see here. I get x plus 5 over what happens on bottom here. I get, this is going to be x plus 5. No, sorry. Yeah, x plus 5 times two numbers that multiply to 14 and add to 9. No, not x plus 5. This is going to be x plus 7 times x plus 2. And I'm going to change my limit here because this doesn't imply what I wanted it to imply. So this is going to be, let's say, negative 2, right? So if I have this here, well, if I plug in a negative 2, I get an issue on bottom, right? I get a 0 on bottom, which is not going to be any good. Now, I can't factor out this x plus 2, though. So it's still a problem in here. So this is no longer a hole. This is an asymptote. This is a break in the graph. If you cannot factor out the problem child, you don't have an asymptote. You don't have a hole. You have a break in the graph that splits like that, or it splits like this. So it either splits where they both go in opposite directions, or they split where they both go in the same direction, either both up or both up or both down. But this is an asymptote or a split in the graph because I cannot factor out the issue. So instead, I have to rely on, okay, well, what's it going to approach there? So if I plug in a negative 2, what's going to happen? Well, this is going to be 0. This is going to be 5. What's 5 times 0? Well, it's going to be a 0. So I'm going to end up with x plus 5 over 0. So how can I interpret what's going to happen there, right? Is it going to be a negative infinity? Because we just said here, right, that if your limit is something over 0, it's going to go towards one of the infinities, either positive or negative. Well, right now, if I plug in an x of negative 2, I can actually do that on top as well. So I can say that this is going to be negative 2 plus 5. I can get this down to an actual number here, 3 over 0, right? I can plug in negative 2 to all my x's, both on top and on bottom. So what is 3 going to 0 be? Is it going to be both going up to positive infinity? Is it going to be both going down to negative infinity? Or is it going to be split and it's going to be a does not exist? Well, if you have your graph, you can do it on your graph. So you actually just, again, type in the function x plus 5 over x squared plus 9 plus 14. And you can see what's going to happen there just directly on the graph here. Okay, well, what happens at negative 2? Well, it looks like negative 2, you can see here, it's going to split down on the left side. It's going to split up on the right side. And so this is going to be another does not exist. Because, again, the splits disagree. The left side says, hey, we're going to negative infinity. The right side says, no, we're going to positive infinity. Since they can't agree, we say that the limit does not exist there. Now, how can I tell that without relying on the graph? Well, you can use a table. So again, you just plug in points that are to the left of negative 2, so less than negative 2, and plug in points that are more than negative 2 as they approach. So what's less than negative 2? Negative 3, right? So let's go from negative 3 and whittle our way down to negative 2. So we have negative 3, we have negative 2.5, we have negative 2.1, right? So we're getting closer and closer to negative 2. Once we hit negative 2, we have an issue, obviously. And then what about numbers that are bigger than negative 2? Well, that'd be negative 1. And then we're going to slowly work our way down to negative 2. So negative 1, negative 1.5, negative 1.9, right? Well, again, looking here, these are all positive. Negative 1, negative 1.9, negative 1.99. There we go. I could just do negative 1. I just think I misclicked there, didn't I? Yeah, there we go. Okay, so as we get closer to 2 on the positive side, on the right-hand side, they're getting bigger and bigger and bigger. As we go to the left-hand side, they're getting smaller and smaller and smaller and smaller, making sure my mic doesn't cut out here. So what does that mean? Well, that means that, again, since they do not agree, since this side says, hey, we're going down, this side says, no, hey, we're going up, then it's a does not exist issue there, because the right and the left-hand sides of the negative 2 do not agree. The lower end and the higher end of the negative 2 do not agree on the direction. Now, what if you don't have a calculator at all? How can you tell this? You have to kind of play around with the signs a little bit. So if you don't have a calculator at all, what you would do here is say, okay, I'm going to plug in a number that is pretty close to negative 2, but less than it. So, for example, negative 3. Well, if I plug in a negative 3, what's going to happen on top? Well, on top, if I plug in negative 3 sign-wise, I don't really care number-wise, but sign-wise, what's going to happen? Well, a negative 3 on top is going to be a positive 2, so it's going to be a positive number on top. If I plug a negative 3 on bottom, this would be a 4, this would be a 1, And so, no, sorry, this would be a 4, this would be a negative 1. Positive 4 times negative 1 is going to be a negative, so I'm going to have a negative number on bottom. And so together, a positive number on top and a negative number on bottom is going to get me a negative number overall. So if I go less than negative 2, I end up getting a negative number total. I don't really know what it is, I just know it's going to be negative. If I plug in numbers that are more than negative 2, what happens? So if I plug in let's say negative 1, because again, it's more than negative 2. So if I plug in negative 1 on top, I get a positive 4, so positive. If I plug in negative 1 in on bottom, a negative 1 plus 7 is 6. Negative 1 plus 2 is 2, or is 1 rather. 6 times 1 is 6. It's going to be another positive number. So I'm going to end up getting a positive number overall. A positive number divided by a positive number is still a positive number. And so this is where the disconnect happens, right? This is a negative number going to be over here. This is a positive number if I come in from this direction. Therefore, they disagree, and so it's another does not exists, right? And again, you just have to pick a number that's less than negative 2. What kind of sign is it going to have? Pick a number that's more than negative 2. What kind of sign is it going to have? If the two signs agree when you're all through and done, then you have positive infinity or you have negative infinity. If these were both negative, I'd have negative infinity. If these were both positive, I have positive infinity. But because they disagree, it's a does not exists. Right? Again, I don't know how much use of a calculator you're going to have when you have this problem here. And then you have sort of the tricky one. So for example, the limit as x approaches 4. Well, again, plug it in. Can it work? Well, 4 squared is 16. 16 minus 16 is 0. Negative 3 divided by 0, we can't have that. So I can't just plug it in, unfortunately. But I can factor the bottom. Let's see what happens there. Maybe I can factor out a problem child here, right? So negative 3 over x minus 4, x plus 4. Well, unfortunately, I still cannot factor out that problem child, right? I cannot factor out that x minus 4. So what do? I check. If x is less than 4, what kind of sign am I going to have? A positive or negative number at the end? Well, if I plug in what's a number less than negative? What's a number less than 4? 3. If I plug in a 3, what's going to happen on top? What's going to stay negative 3? It's going to stay negative. What's going to happen on bottom? If I plug in a 3, this will be negative 1. This will be positive 7. Negative 1 times positive 7 is negative, and therefore these are going to end up being positive. What's a number that's more than 4? 5. If I plug in a 5, top part's still going to be negative. If I plug in a 5 here, I get positive 1. If I plug in a 5 here, I get positive 9. 1 times 9 is going to be positive. So a negative over a positive is going to be a negative. Do these agree? No, they do not. This one says, hey, we're going up. Nope, this one says, hey, we're going down. And so because they disagree, this is another does not exist, which I seem to be picking a lot. I'm just picking these numbers for ease of thinking here. So I don't mean to put a bunch of does not exist here. But again, if these were both agreeing on the direction, then it would obviously be that value there. So for example, let's say I do a little subnote here. Let's say this was just negative 3 over x minus 4. I think that might work. Let me check on my graph here. I'm trying to pick one that's not a does not exists. Negative 3 over x minus 4. Would that work as an exists one here? Nope, that would also be another does not exist, unfortunately. I'm having trouble thinking of what these would be off the top of my head. If I do a square here, let's see if that changes anything. Give me one second. I'm trying to pick a good one here, but again, kind of hard to come up with them off the top of my head. There we go. So if I do a x minus 4 squared here, and so again, the same thing, limit as x approaches 4 of this function here. Well, again, can't plug in a 4 directly because I get 0 squared, which is 0. So what's a number that's less than 4? 3. If I plug in a 3, I get a negative 3, so negative, over 3 minus 4 is a negative 1. Squared is going to give me a positive 1. So a negative over a positive is a negative. What's a number that's more than 4? 5. If I plug in a 5, top is still negative 3, still negative. The bottom is going to be 5 minus 4, which is 1. 1 squared is still positive 1, which is going to give me a negative overall. And so a negative over a negative, or sorry, this side here rather, this side here says, hey, we're going down. This side here says, yep, I agree. And therefore my limit is going to be negative infinity. And again, you can see that on the graph. They both shoot down. They both agree, hey, we're going to drop off the graph, and so we're both going to head towards negative infinity, and so the limit is negative infinity, right? So again, you just have to kind of plug in numbers and see. Your main concern is not, once you know that the bottom's going to be 0, you know it's going to be 0, or you know it's going to be infinity or negative infinity or does not exist. Those are your only 3 options at this point, at least. If your bottom is 0, the options are negative infinity, positive infinity, or does not exist. Your goal to figure out which one of those 3 is to look at your signs. And so you want to figure out, sign, I don't really care number-wise, but sign-wise, how's it going to end up if I go from the left? How's it going to end up if I go from the right? And then together, what can I interpret from that? If you have a piecewise function, that muddles things up a little bit here. So this is the trick people think. They say, okay, the limit as x approaches 2 of this function. Well, hey, it says if x is 2, the function is 10, so therefore the limit is 10, right? Not quite, because the function has a 10 at x is 2, but that's not actually the limit, because the limit is what is x approaching as it gets towards 2. Well, we have to look around the point, not on the point in this case, because it's a piecewise function. So if this is where x is 2, so I have a graph here, right? And this is where x is 2. My graph is doing its thing. Once it hits 2, there's like a little hole there, and it jumps up to 10, and then it keeps doing its thing. Well, the limit is not 10. The limit is actually right here. It's what number the graph is approaching from the left and from the right as it gets closer and closer and closer to 2, which is not the same thing as in this case as 10. Sometimes it can be, but in this case it's not, because what I'm going to do is I'm going to put this 2, I'm going to check it for this guy here. And you might be saying, well, that's when x is not 2. Why would I be checking it that way? Again, I'm not really, this is going to sound counterintuitive. I'm not really interested in what x is when it's at 2 in this case. I'm interested in what x is looking like it's going towards as it's moving towards 2. Well, if it's moving towards 2, by definition, it's not on 2. And therefore, I really don't care about this part of the piecewise. I care about this part, because this is the part where this is the road x is taking when it is not on 2, but it's going towards 2. And if I plug a 2 in here, I think my mic cut out there. Let me check real quick. Am I still recording? Okay, good. So, as I was saying, when x is traveling down this road, it's going down this function path, this road here. And so when I plug a 2 in here, 2 times 2 plus 5 is going to give me 9. So the limit as x approaches 2 in this case is actually going to be 9, because that's the value that it's going towards, even though that once it reaches 2, it's going to jump up to 10. That's not my concern. My concern is what's it looking like it's going to, and then in this case, what it looks like it's going to is 9. It actually is going to end up being 10, but again, I'm not concerned with what it is at that value. I'm concerned with what it's approaching at that value. Again, this is how x looks like, or how x behaves as it's, or the function rather behaves as x approaches 2. Not when x gets to 2, but as x approaches 2. That's a special thing for piecewise. Now you might be saying, well, didn't you just contradict yourself? Because over here, when we first started this, you said, well, if you can plug in the number, well, then plug in the number. Yes, but this isn't a piecewise function. That's basically the gist of it, right? If it's a piecewise function, you have to take a special little precaution and make sure you don't fall for that trap, because it is a very common trap. But if it's not a piecewise function, then yes, your first step is to actually plug in the number to see what's happening. But in that case, in this case rather, it is a piecewise function, therefore I can't use that trick, right? That trick works for everything but piecewise, right? So those are the ones that I kind of picked as to kind of help you out with the basics of limits here. Usually, again, if I have something like the limit as x approaches 0, with addition and subtraction, it's really not that more complicated. If I have something like 5 over x plus 4, well, if I plug in a 0, I'm going to have an issue. But what do we say? A number over 0 is going to go towards one of the infinities, right? So let me do x squared, actually. X squared, because this is going to make it a little bit easier. So as x approaches 0, it's going to head either to positive infinity, to negative infinity, or it's not going to exist. This 4 is basically irrelevant. So what happens as x goes to 0? Well, again, let's pick numbers that are to the left and to the right of 0 to see what happens. Well, if it's to the left of 0, let's say -1. If I plug in a -1, 5 is still going to be positive. -1 squared is going to be positive, and therefore this is going to be positive. If I plug in a +1, 5 is going to be positive. 1 squared is going to be positive, and therefore this is going to be positive. So it looks like that as x gets to 0, this is going to get closer and closer to positive infinity. Well, what's positive infinity plus 4? still positive infinity. That's why the plus and minus 4 has no bearing. If this is a minus 4, I'd say the exact same thing. What's this going to be when it's minus 4? Well, infinity minus 4 is still going to keep going towards infinity. Infinity is not a number, but if you take a very large positive number and subtract 4, you're still going to have a very large positive number. So this is still going to end up approaching infinity either way. If this was a negative infinity, so let's say it wasn't, if it was, I don't know, but if this was a negative infinity instead, then the answer would still be negative infinity, because adding 4 to a negative infinity or subtracting 4 from a negative infinity is still going to get you negative infinity. You're still just dealing with such a large difference in size there at that point that the 4 is irrelevant, or the 10, or the 20, or the 10 billion. The addition and subtractions just kind of fade away when they're attached like this, because the limit takes care of that essentially. Um, or the infinity rather takes care of that essentially. The only issue that you might have is if your limit approaches 0. So the limit, as I'm just going to do a real simple one here, the limit of 2x plus 4 as x goes to 0. Now I know you can plug this one in, but let's say you couldn't, you were trying to check here, and you found that this approaches 0 as x goes to 0. Well, what's 0 plus 4? Well, that I can do. That's 4. So the limit as x goes to 0 here is indeed 4. So in this case, the plus and the minus does matter, because this isn't going to an infinity. This is going to a solid number. So if you find that your x part of the problem goes to a number, then simply take that number and then add or subtract it to the 4, the 5, or the whatever number is being added or subtracted there. So whenever you have an addition or subtraction, ignore it until you figure out what's happening with the x part. Once you know what's happening to the x part, if it's an infinity, I really don't care what's happening over there. I'm just going to stick with my infinity answer. If it does not exist, again, I don't care what's happening on the plus side. I'm just going to stick with does not exist. If I get to a single number, like a 0 or a 5 or a 1/7, then I can worry about what's going to happen when I added something in there. So where's the other one we did? This one right here. If I had this plus 10, then my limit as x approaches 5 would be this plus 10, whatever that value is right there, whatever that decimal would be. Because this x part is approaching a number, and therefore I'm going to add 10 at the end to get my actual limit there. If I did it over here, if this was a plus 10, it'd still be does not exist, because the plus 10 is not going to change the fact that I'm shooting in two different directions, and therefore it's going to mess up my whole thing there. So again, the addition subtraction part, as long as there's no x involved, doesn't really impact your limit until the very end if you're approaching a single number. If you're not approaching a number but you're approaching an infinity or it does not exist, then you can just forget about it entirely. So that's my little spiel about limits. Hopefully it helped you out with the basics. You can let me know any questions, comments, or concerns you have. I'd be glad to try to help you out as much as I can. Thank you for watching.